Good afternoon, good morning, good evening, everybody. This is Barry Braster with Edaplan. About to start the webinar for today with the topic connecting STE to IoT. There are some questions, but I will ask you to ask those unless you cannot hear me for whatever reason during this session. So let's go ahead and get started, shall we? Okay, so to briefly explain who I am, just to briefly introduce to you, my name is Barry Braster. I'm the Technology Director of Technical Documentation at Edaplan. Number of years in technical documentation, as you can see, and on the left part of your screen you can see my contact details in case of any questions, or feel free to contact me on LinkedIn or follow me on Twitter. Before we get started, a few household things with regards to how this works. It's a 30-minute webinar. I will leave the last 5 minutes for questions and, of course, hopefully answers. The audio is provided through your PC speakers or by simply calling in. You should have received the number in the invite that you received. And then today's webinar will be recorded. In case you would like to receive a link, you can request one afterwards by sending an email to barry.braster@edaplan.com. Otherwise, for all of those who registered, will all automatically receive a link after the recording has been finished. So ask questions, absolutely. I will try to answer all of them towards the end of the presentation. So that being said, a little bit about us before I get to the main topic. Edaplan, for those of you who are not familiar with us, we were established in 1983. Over 2,800 experts today, of which 550 are in technical documentation. So we have close to 550 authors, illustrators, people working in the tech doc field. And then we are a publicly listed firm. That means that we also give our numbers on revenue, and that's the number for 2017. So, and the picture in the back is not all 100 or not all 2,800, but we try to fit most of them in there. So, we provide three main level of service areas. Engineering is, I would say, our core business with over 1,600 engineers. But with 550 people in TechDoc, we are not necessarily small in that area as well. And then we have approximately 400 folks working in embedded systems and IoT. And what we are trying to do with that is we try to support the full life cycle of our customers' products by going from engineering to TechDoc that comes with that, as well as being able to connect to IoT. And I wanted to talk to you a little bit about IoT and what our role is in that. So those 400 plus people that I spoke about are actually helping our customers design products and solutions, embed those products. So we help design, let's say, sensors that are then connected to the cloud, where we also provide services there, where we are able to analyze the data and actually do something with that, come to conclusions and use that data, and then also make that then revert back to an added value by providing services for applications and user interfaces as well. And basically that tells you that the information that comes from IoT, how that can then be turned back to an end user so that they can actually use that data. A nice example actually of that is one of our customers, Enevo. They asked us to help them create and design a sensor, a smart sensor, that is actually a core component that uses wireless sensors to measure and forecast actually fill level of waste containers, so garbage cans. And that service actually automatically generates schedules and optimizes the routes for garbage collection. So these are done in Finland. A really nice example of how you can actually use IoT to optimize, in this case, the routes for garbage collection, which can save a lot of time and cost, of course. So, okay, so up to today's topic with regards to connecting STE to IoT. I think what I would like to do first is kind of draw the bigger picture here for you by first looking at the top strategic technology trends for 2018. I'm probably not saying anything crazy here when I talk about the fact that, products and machines are becoming more intelligent. It's not something for the future. It's actually happening today already. So the intelligence of things, right? Thanks to these types of sensors that are connected to devices. Refrigerators are, for instance, able to let you know when it's time to order a new carbonated milk, for instance. And on the other hand, we have digitalization taking place, where all product information, or information products, if you will, are becoming digital. Everything is going to go to the clouds. Could be, of course, a protected cloud, or a cloud available to everyone. We will need digital twins of our products in order to connect to IoT, in order to make that connection between IoT to technical documentation, and also, for instance, go towards the immersive experience like augmented or virtual reality. We all need these things. And then the third part, of course, is to connect all of those things together, and also realize that they are, we're going to go towards something that is more event driven rather than passively driven, so to speak. So that being said, the next part is then to talk a little bit about the impact of that on technical documentation. And with that, I would like to make emphasize on the service and aftermarket business. Why? Because the service business, or aftermarket, or maintenance business, however you want to call it, is actually increasingly seen as a strategic business function. Companies, manufacturers are not necessarily, or are getting closer to not already selling their machines, and then whatever happens after that, of course, you want to service them, but basically being able to provide those machines at no cost to the customers, and then charge them based on the use. And if you do that, that's a totally different model, of course, but that means that the more it's being used, the more money the manufacturer makes, but also the happier the customers, because they can use it. So in other words, you get into a model where both the manufacturer as well as the customer benefit from the optimized use of a machine. And that's what basically IoT will allow you to do. So it's not so much about how IoT is connecting assets and devices. It's actually about how the world is changing and going to a different model, improving the service, building better products, and boosting workforce productivity. And if we then look at the top goals for service asked by, in this case, Aberdeen Group, then of course companies are looking to improve the customer retention, improve service-related profitability. Of course, someone has to pay for it, but improve quality relevance of service data. And now that's where I get with regards to technical documentation and how it's connected to STE later on in this presentation. And you basically can see, if you go down the line of other things that people are looking to better. And with IoT and TechDoc connected, you're actually able to go from reactive to predictive maintenance. So where before you received a service call that then had to be scheduled, the service mechanic had to go to, let's say, the factory, see what the problem area or what the problem was, not having the right part with him or her. Scheduling something new. In other words, long story short, is in today's model, it can be a lengthy and therefore costly process. And we know that, and that's why we're going towards IoT, right? So, but thanks to IoT, you're actually able to go to predictive maintenance, because those sensors will be able to tell you when a certain part or component will start to wear out, and therefore send out the service mechanic with the right part, with the right information, so that he or she can replace the part before it even goes down. And that means that there's a massive gap, a massive part to improve profitability or lower the cost, and basically solve a lot of problems before they even happen. So with IoT, service organizations and OEM/manufacturers can remotely diagnose and repair customer equipment, but also proactively address maintenance issues and improve first-time fix rates by quite a bit. And this is kind of the bigger picture again then. So again, to let you know, so these are the sensors on the devices that send data into the cloud that are then being brought over for real-time analytics, right? So you can actually do something with that data. So that's the part that my colleagues of IoT are doing up here. And as technology director for technical documentation, I'm kind of in this area right here where we have our information, whether it's user information or assembly or maintenance information, that all sits here. But there's, of course, we have to find a way to connect all of this. Why? So that we can send that service guy or girl out there with the right information, with the right parts in order to be able to do preventive maintenance. And then, of course, give him or her the means to do his or her job as effective as possible. But then, of course, there's also how do we connect to other parts like solutions like augmented or virtual reality. And in this case, we did a nice project for Koning. As you can read here, where we were able to, for their Salesforce, create this this app to allow customers to basically configure their own elevator. But in addition to that, we also want to go towards the wow factor, or past the wow factor, I should say. The objectives, therefore, we should look at. So what are and should the objectives be for augmented and virtual reality applications? Not just about, oh, this is great that it's on augmented reality, let's use that. No, actually, what problem does it solve? How can we minimize the time to find and troubleshoot the issues? How can we provide an engaging way to give information to an end user rather than a 2,000-page manual? Can we do that in the form of augmented reality? And even if we do not use augmented reality, it still needs to be engaging, right? So you could provide someone with a 2,000-page manual, but now in the form of a PDF, but he or she will still have to scroll through that, but now on their laptop. So it needs to be easy to understand, give quick and easy access to the information that they need. Being able to learn, right, and training, so knowledge transfer is really important, specifically in today's age, where a lot of our mechanics are retiring, and we need the young folks to be able to take over that, who, of course, want to bring the home experience to work, where they are at home used to working with mobile devices and tablets, and at work they're being given a 2,000-page paper manual. That's not the way to go forward, of course. Connect that to spare parts ordering, provide, do feedback management by providing feedback function to keep information up to date. Ability to get published on multiple devices, and of course to connect everything. And that's what I'll talk about later on as well, the need for basically to have everything to go, not necessarily one system, but to connect all the systems together. So, which means a few considerations, right? So we need to realize that content becomes much more precise and technical. And when I say that, I almost want to say it also becomes more context sensitive. So we even have to take emotions, for instance, into consideration, or even being able to link everything, content, to how it's being used for artificial intelligence, so that machines actually learn. Well, you still need content for that. Content creation becomes therefore also much more collaborative, meaning that we need to have the different silos. If you have product development where user information and assembly information is, and then we have service information being a different silo, well, that's something that we can really no longer have. We need to be much more collaborative in that and get rid of these silos. Content creation then also becomes one part in a total system. Not so much that you need one software tool to manage everything, but it's about connectivity. And in order to connectivity, content needs to meet certain requirements, which I will discuss in a moment. So, and that also means that content activities become more complex in the end. And what does that mean, right? So the implications for how we create and manage technical content information. Of course, there's XML. Now, we use DITA by default, but aerospace and defense S1000D or airlines ATI ISPEC 2200. There are standards out there that can help you get there, in essence, is what I'm saying. They help you structure your content, but they also allow for topic-based authoring. And that topic-based authoring allows us to create small topics, I would even call them molecular parts of information that you can use, which is really the area where we're going towards to. We went from, I don't know, I mean, if you're talking about IoT and Industry 4.0, well, this is kind of like information 4.0 for that matter. That XML will not only allow you to reuse, and it will be easier to manage and, allow for data exchange, but it allows you for that connectivity later on, which I will discuss in a moment. Now, STE, Simplified English, for clarity, is actually plays a big, important role here. Simplified illustrations as well. That's kind of that digital twin that I mentioned earlier on. And of course, last but not least is you cannot give all these methods and tooling to your authors and illustrators and think that they are then good to go. No, of course, training is necessary, experience is necessary in order to be able to get the best out of it. Now, this is kind of where at Ediplan we see the technical documentation maturity model as it is today, and that's kind of that dark line over here is where it is kind of today, where we started out with content writing, your basic service manual, to applying standards like Simplified English and Simplified Illustrations, going towards structured information, single source publishing, and then the idea is as we go and continue further towards IoT, towards information 4.0, is that we get feedback, we are able to communicate or have information communicate between different equipment, systems, documentation, service personnel, etc., in order to get the right information at the right place in the right time. And then being able to further automate that. In other words, cost savings in the end will go up as well as quality, but it's also about that connectivity. So a little bit more about Simplified English, because I mentioned already the topic of today is connecting STE with IoT. For those of you who are not familiar with STE, it stands for Simplified Technical English, and it's kind of the global standard for content quality in authoring. Now, there are other standards out there, of course, but this is the standard that we kind of see as the one that really tries to pursue clarity and consistency. And to be honest, if you have all of these standards and you put them next to each other, I would say about 80 to 90% talks about the same thing anyway, where, how to basically write in simple and clear English so that it's easy to understand by a global audience. So it ensures clarity. It ensures safe product use. It can reduce your translation and documentation costs actually up to 40%. But how does it actually connect your content to IoT? How is it actually becoming future-proof? Well, an easy example, of course, would be that information is needing to be shown on, different types of devices. Sure, on the tablet you have more space, but we more and more use mobile devices for that, like these cell phones over here. And if you have something, a procedure like the material may be damaged or the operation of the product affected, if the installation procedure is not followed correctly, then of course it's much better if you make that much more concise by saying to prevent damage, do the procedures correctly. So it's a lot less space that you need, and you need that less space because your devices are becoming, well, the device is actually becoming smaller, or bigger, I would say, with these plus phones, etc. But I guess I'm assuming you get my point here, that you have the user attention that is quite limited, and they need to be able to simply see something simple and easy to understand, easy to use, and get on with it. So, and that's kind of how that plays a bigger part there. But then connecting it to IoT. So knowing, as I previously mentioned, that IoT enables real-time data, context sensitivity, so context awareness. So information must also be responsive. Information must also be molecular, right? And then you achieve that by going through that structure approach that I just mentioned. So with STE, you achieve clarity and a structure that better facilitates use in IoT thanks to clear and concise use of topics. And I mentioned that already in this previous example by using this versus this over here. So it will support your digitalization IoT strategies even better. Thinking about it, your end user, in all honesty, doesn't really care how it's all connected. They just look at their screen and they're being told to do something, or they're being asked for information. That information, of course, needs to be clear, concise, and easy to understand. Easy to translate for that matter as well. So that means that let's briefly go to this one, that the technical communication actually is in the center of IoT and Information 4.0. And I'll get back to that in a moment. But to briefly mention a little bit about HyperST, our content quality software. It's in use by quite a number of companies and industries worldwide. This is something that you can ask me more information about later on, but it actually helps to create, to meet your short-term business goals by getting your documentation and translation costs down, and at the same time help you facilitate going towards IoT strategies, as I mentioned already, in the a little bit longer run, I would say. So the next steps then is connectivity, where we, in this case, it all kind of comes together in this user interface. So you have a user interface that you give to your service engineer, as an example. You have these new sensor alarms that are coming from the factory. As a matter of fact, you can actually see on the map, thanks to these sensors, again, you can see where the problem is, which factory, which product, which model of that product, which customer, etc., etc. Thanks to connectivity in the ERP system, you know exactly where and who to assign, where to go to and who to assign. And then you're able to basically collect all the data and then provide your service engineers with step-to-step procedures on how to basically fix the issues. All in simplified English, using the digital twin to get information in the form of this simplified illustration, for instance. Get the spare parts, the tools that you need, and go through a step-by-step procedure, which essentially will lead to a seal of approval. And it's all in the cloud, it's all digital, and we all make ourselves more lean that way. So you provide up-to-date information to your field service, reduce downtime, as a matter of fact, prevent downtime, improve your service business, and as a result create or help create new revenue streams. So the next step then, to round things up here for the technical communicator is, of course, as I mentioned already, realize that technical communication is not going away. As a matter of fact, I would argue that it's in the center of IoT and Information 4.0, which means that there is going to be a need for a constant delivery or real-time availability of that content. And that content then needs to be molecular, as I mentioned. So we need to think about the content strategy. We need to look at the engineering models that we have and the methodologies that we use to create and manage and publish content, right? So it's no longer about adding tags for findability, but it's now also about creating tags, for instance, that take care or that take into account emotions, as an example, in order to, for instance, be able later on connect to artificial intelligence methods. The delivery models, it's no longer about delivering information to the end user and say good luck with it. No, it's about it's event driven. So the delivery models need to be event driven as well. At least they need to facilitate that. So we need to include, okay, what's the part that AR now or eventually will play in order to make things better, and what's the role, of course, of systems. Now, this, I mentioned systems, it's on purpose, it's later on mentioned. The last thing we always advise to do our customers is to look at systems first and then decide what your content strategy should be. No, it should be the other way around. Have your content strategy set up knowing that you need to do all of these things, or at least think about which things you need to think of in the future, and then look for systems that will allow you to create that connectivity. And then basically move forward. That rounds things up. It's 3:25, so that leaves me for 5 minutes for questions that hopefully you will have. So let me open up the question box. Feel free to ask me anything you want. And if there are no questions, then I have an easy afternoon, of course. You can, of course, also ask me by sending me an email at barry.braster@adaplan.com. These are the websites also to visit. And I think, yeah. Was I that clear, everyone? I guess I was. All right. Oh, there are some questions coming in. What are the trends in technical writing after single source publishing in your maturity model? I would say the trends in technical writing is that single source publishing is now being expanded or extended, I should say. I would say that the trends are really about applying the right metadata to your content. And that's not just about, product use or division or etc. It's becoming much more complex when we go towards information 4.0 with artificial intelligence also now taking place. So that's something to really think about. But I would say that once you have your single sourcing strategy in place, in addition to simplified English and the use of a digital twin, you are already quite a lot on your way. It's about, once you have that, it's simply about extending it and opening it up to more connectivity. What types of industries are using this? Paul is asking. Let me just open up the questionnaire so that I can actually see it. What types of industries are leading this? I would say the manufacturing industries. And the manufacturing industries, mainly heavy equipment. I would say also in the field of agriculture. So companies and their customers who really benefit from having downtime minimized as possible. And that, of course, also includes medical devices. So think about MT CT or MRI equipment as an example, because lives depend on that. What is then IoT? It stands for Internet of Things, Anthony, and I would suggest that if you have received or viewed everything, I will send you a link afterwards, because in the beginning of the presentation I explained that. Rob is then asking, what skills in technical writing will be needed for the future of information 4.0? I would say the skills of getting trained in simplified English, getting trained in the use of XML, and specifically, well, I would say more preferably the use of DITA, and then go from there. Making that connectivity to IoT eventually means metadata, and that way systems can help, but also methodologies. So I would say that specifically starting to look at metadata, how we can incorporate the connectivity to things like Watson, for instance, is something that we need to start looking at. Okay, I think that is it. Then I would like to thank everyone for attending. Again, a link will be made available after I shut down the webinar itself, after I stop recording, I should say. I need to talk simplified English more myself. And then you have my contact information in case of any questions at all. So you're all very welcome. Have a good day or evening or morning for wherever you're calling from, because we have a large international audience, I know. And then we will be in touch soon with more webinars. Thank you. Bye-bye.